Hi, I'm John Lockwood. I'm going to talk today about moving ad exchanges from Main Street to Wall Street. And so this is an idea of revolutionizing a data center by taking AdTech technology, upgrading it to the technology that Wall Street's been using to make high-speed exchanges. So today's AdTech requires time to parse bid requests, look up relevant data about a user, evaluate an opportunity, decide on the value of an ad, and price a bid to serve an impression on a web page. So the real-time bidding protocol serves hundreds of billions of ads daily on about 100 different demand-side platforms, moving hundreds of terabytes of data back and forth through ad exchanges to serve up ad impressions. So the AdTech bidding ecosystem allows users that are visiting publishers' web pages have supply opportunities for ad impressions. And multiple advertisers compete for the opportunity to display an ad, and the ad exchange auctions space for the impressions. And so as we can see in the picture is that the publisher has space, that's supply side, and the advertisers are the demand side. And so either the advertisers themselves are going through an agency, is that they're buying, looking for the best way to reach their customers. And so every time that there's an opportunity on a page to show an impression is that an auction occurs, and that auction allows the best bidder to match up with the best publisher that has an opportunity to show that ad. The motivation for this is that improvements are necessary to get better transparency and better price discovery for the ad tech markets. Is that it is known that multiple rounds of bidding generate better prices than single round. And the financial markets in the United States and around the world now are very efficient, and they provide a continuous auction for the equities, commodities, and futures that are sold every day. And we could take that technology that's being used on Wall Street and bring it into the ad tech market and have a much more efficient ad tech market. And so using that, we'll use the equity trading as an example for how we could improve the ad tech market. And so specifically, I want to talk about how we can monitor live market data feeds and compute an order book with an FPGA so that as we're bidding, we can see that we have visibility into the best bid and ask prices of the prices. And so Algo-Logic has implemented what we call a gateway-defined networking Capi-enabled order book that can be applied to the real-time bidding problem, RTB, and it provides a way to get visibility into the the bid and ask side of the pricing. And so the order book as part of the solution would look like this, is that the exchange is, and I'll talk in this about the way that the equity exchanges work, is that the exchange feeds out through multicast UDP a set of market data messages that give the pricing. And so those prices are every time that there's a bidder or there's a supplier that changes the price on the bid or ask side, that gets broadcast out to the world. So there's full visibility and transparency to all the participants on what the bid and offers are. And to keep track of the best prices, you have to have an order book. And so the exchange maintains a queue of the best bids and the best ask for each of the items that are being sold. But you as a bidder also want to have a mirror copy of that. And so that order book can be replicated. You want to have a mirror copy that replicated so that you have transparency and you can see what the best bid and ask price is. And so based on that, your trading logic can decide if you want to up your bid or if you want to put additional offers into the market to buy that ad opportunity. And so this implementation on the Power 8 that Algo-Logic has built looks as follows, is that we have an FPGA card. This is a Nullitech FPGA, a P3D5, that has a Capi bus that connects to the Power 8, and it has Ethernet ports. And so on the Ethernet ports, the SFP+ ports, live market data streams in, and in the AFU we have logic, which is implementing the order book, and then through the PSL, which is IBM's Power Service Layer, is that we're sending data across the coherent bus to the Power 8 processor. And so as the system's running, the exchange is feeding this multicast data, is feeding into the Algo-Logic order book, and through the Power Service Layer, we're pushing those updates, which are the snapshots of what the current market is, down into the Power 8 processor, which goes into shared memory. And so as a result, that the application can be a standard user space application running in software, so no modifications to the software are needed, except that they can see at any given time all the different bids and ask prices for the ad that they're looking to buy. And so shown here is what this looks like live when it's deployed in an equity market, which is how it's being used today. And so you can see the number of stocks are being shown. And so hardware is computing the bid-ask books, parsing the market data, populating shared memory. In this case, all that software is doing is simply plotting over time how the book changes. And so we can see that for some number of different stock symbols, over time, that the blue and the red lines represent how the bid and ask prices are collapsing and expanding as buyers and sellers come into the market, and the green line shows the last trade. And so it provides a fair way to achieve a bid. It's much like being in an open auction where you can hear the bidders and askers, and you've got a chart that shows you the best bid prices. So specifically, the data structure that comes out of the Capi order book shows you the set of buy levels and sell levels, and so that you can see what prices each of the different levels are priced at. And you can see that in the 128-byte structure is that you get an image, a snapshot, where software now can make a rational decision on where it should be bidding. And so as this streams over time is that the bid and ask prices I mentioned before change. And so as the price changes for equities, for example, here, the Altera stock price, you can see how as bids and asks move is that the book can open, it can expand and contract. But both on the buy side and the sell side, you've got visibility, you've got transparency into the market. And so it really makes this a much more fair market and a much more open market that your advertisers want to sell into or buy from. So we've done live demonstrations of the Capi order book. We showed this last year with the equities. And so in that case is that we had the Nullitech card taking in live market data. And so this was a NASDAQ itch feed coming in from market replay. And then we fed that into the Power 8 processor and then ran the software to plot out the results of the order books. And so we have a software API so that you can tell the hardware card exactly which instruments that you're interested in trading. And then based on how you populate those registers, the hardware device, the Capi card, will monitor that symbol and generate the charts for you. So usually, in the equities case, these markets are continuous markets open all day, as, for example, stock price is trading, but in the case of AdTech, the opportunity opens and closes. And so, for example, a user hits a web page, an impression pops up, you disseminate market data out to the public or out to your buyers and give them the opportunity to bid on that impression. And you need to close that deal within milliseconds. And so today, that's being done with a single round auction where you have one chance to tell your bidders that here's an opportunity to advertise, and they get one response to respond back with the best price. But as we know, that's not the best way to run an auction. A one-round auction is not effective. A multi-round auction where it's continuous and you can see the competitive forces in play make this a much more better market for both the buyers and the sellers, and to get real price discovery and the best value for all the players. And so it may seem not feasible to have within milliseconds a multi-round auction, but in the equity space is that Algo-Logic has been implementing for high-frequency traders, we implement order books that provide updates on the order of microseconds. And so within a microsecond, we can take market data in, update the order book, and push that out to shared memory. And so that the control loop of having an auction, within milliseconds, we can actually have hundreds of rounds pass back and forth. And then at the end of that, say at the end of 10 milliseconds, we can close out the auction and start a new one. And so it actually fits very well within the model that we developed or that we used for the options or for the equity trading, because we already have all the infrastructure to create the auction, run the auction, and close the auction, and we have some microsecond level speeds that happen. And so it's entirely feasible that this model applies perfectly to the AdTech space, because we can start, run, and close an auction in milliseconds with microsecond speed transactions going on. And so just to show the speed of this is that we've done benchmarks of the Capi-enabled order book, and starting from the PHI-MAC, which is where market data comes in from the exchange over Ethernet, to building the order book, to going across the IBM PSL, to going through the Capi interface and getting through the cache and getting to the C application that's running on the Power 8 is that total time it takes to go from outside of the machine to the user application that's running is about 1.588 microseconds. And so in just 1.5 microseconds, which is about 1,000th of a millisecond, we're able to get market data into the machine. And we can respond in a similar amount of time. So that means within a few microseconds, we can turn around a transaction, a bid, and go back to the market and continue. So that makes room for hundreds of potentially hundreds of rounds, but certainly plenty of rounds to do good price discovery. So thank you. Any questions?